I told you, if it's a graph, okay, it has to be a line, okay? I want you guys to roughly sketch these two graphs. Doesn't have to be perfect, okay? I just need two coordinate planes. You don't have to even put the coordinates, and just draw the two lines that you see here, okay? One is a curve and the other one's a straight line. If you have graph paper, do it on your graph paper. If you don't, okay, just do it on your line paper to the best of your abilities. But I want you to copy down A and B, and then we're going to talk whether they are linear or not and how we know. Is that a straight line? Nick? No. If it's not a straight line, we're going to put an X, and we're going to say it is not non-linear. Easy? Look at this second one. B. Is that a straight line? We're going to put a check, and we're going to say it is linear. Okay? As long as your line does not jag to one side, it's not a curve, it's a straight line, you're good to go. Okay? So, take a look at the next one I'm going to draw. Would this horizontal line be a linear function? Nick?
No.
It's not a trick question. Yes, it would be. Why? JJ? It's a straight line. Okay? It is linear. There is only one straight line that is not a linear function. Does anyone think they know which straight line is not a linear function? Grace?
When it's like up and down vertical.
But why?
Because when you hit it, it's like it's points more than once because it's shifting back.
Okay, you're very close, but think back to our lesson on Friday. What does that mean?
That it's not than one.
Liz?
It doesn't pass the vertical line test.
Okay, you're on the same track as Grace, but what does that mean?
That is not a function.
It's not a function. Very good. Okay? So the only straight line that doesn't work as a linear function is the straight line that is vertical. Please draw this one on your paper, circle it, and put an X next to it. Okay? That is the only straight line that exists that is not a linear function because it's not even a function. Okay? Straight lines are not even functions because they don't pass the vertical line test. Does that make sense? All other linear equations are functions. You have a question?
No.
You sure?
Yeah.
You sure?
Yeah.
Okay. So it's the only straight line that is not a function, a linear function, vertical lines. Okay? All other straight lines are good to go. Okay? Let's try two more examples. All I need you to do on your page is write down a 2-column area and put linear function and nonlinear function. Do not yet write down these equations in the middle. We're going to have to pick whether they go to the left as a linear function or to the right as a nonlinear function. Yeah, Nick?
I have a question for when we're doing the boxes.
Go ahead.
You know that
At y equals x squared. I don't see any off the top of my head. So do we think this is going to be linear or nonlinear? Nonlinear. Because it doesn't exist where m and b could be numbers that would make that happen. Do we see that? Okay. This is your end all be all. mx plus b. Okay. The third one. Y equals 1 divided by x. Do we think that's going to be linear or non-linear? What do you think, Jonathan?
Non-linear.
Non-linear. Very good. Why?
Because there's only there's a fraction, but you can't really make that into mx plus b.
Correct. Why? What's, like, if it was x over 1, though, we could do it.
I mean, technically.
But why is this one different? Gabby?
Because you're not adding anything, so you can't really be everything.
But we could make b 0, right? Then we wouldn't be adding anything. Why is this one different? I agree with you 100%. But Brady, what do you think?
because you're dividing, and when it's mx, it's always multiplying.
Correct. We're dividing by the variable, okay? We're dividing by this variable. Do we all see that? You can't do that, okay? For linear functions, you cannot divide by the variable. JJ, what's up?
No, I just wanted to answer the fourth one.
You want to answer the fourth one? Okay. Do we think, well, JJ, do you think that y equals 4x is a linear or a non-linear function?
Non-linear. Because you're going
Brady, what do you think?
I think it's linear because you can change pages.
Uh-oh, we're being pulled in two directions. JJ, I'm sorry, I agree with Brady, okay? Because what happens, JJ, if you make B equal to 0 and M equal to
4.
4?
Oh,
Do you see that now?
yeah, I do.
The B's going to disappear, right? Because you don't add 0 to anything. But if you made the M 4, you would just get Y equals 4x. Now, stick on a plus 0 here, and you've got exactly what you started with. The more examples we do, trust me, it'll click. It'll click, okay? Let's look at another one. Y equals 3. Could you pick a value for M and B that would match that to Y equals MX plus B? Carson, what do you think?
No. Because there's no variable on the other side.
So M would have to be 0. What if you made M 0?
What does that make that?
Then B would have to be
Oh,
3. Yeah.
So what about the X?
So if we made M 0, right, we would get Y equals M, which is 0, times X plus B, right? Oh, sorry, we made B what? What did we make B? 3. Victor, what is 0 times X?
0 times X would be 2.
Yeah, so what's 0 plus 3? Is that what we were supposed to look for? Jonathan?
Can't we make M1?
Because M1 would keep the X there. Do we have an X in our problem? No, we just have a 3. Do you see that? Let's try a few more examples. Trust me, it's going to click by the end, okay? Y squared equals X. Do we think that's linear or nonlinear? Jonathan?
Linear.
You think so?
Well, now that you're giving me that, I think it's not linear.
If there's anything with an exponent, okay, it's going to be nonlinear. Because we can't pick an M or a B that would get rid of that square, okay? And what about Y equals X over 7 plus 1? This one's a trick one. A lot of people think it's nonlinear. You think it's linear?
Yeah.
Why?
Because it goes with the rule of MX plus B.
Very good. But let's try to figure out what our M and our B should be. Grace, do you think you know?
I think so. So you have to cancel it out from the fraction, so you would do 7 over 1 to multiply.
Super close. But we don't want to solve it. Just think about what would M be to match this and what would B be?
Multiply 7 over 1.
You're on the right track. What do you think?
M would be 7 and B would be 1.
Super close. B is right, but M is wrong.
And would be 1 over 7.
M should be 1 over 7.
Oh.
Because if you had 1 over 7 times X, do you agree that this is the same as X over 7? No? Nick?
It is because when 1 is multiplied by x, the 1 completely disappears.
Mm-hmm.
And
So do we agree that 1 over 7 times X is the same as 1 over 7 times X over 1? You multiply straight across, and you get X over 7. All right, let's do more. Let's do more, because I can see some confused faces, so we're going to do more, all right? Don't write these. Copy down tables 1 or A and B. We're on part 2 of 3 of this lesson. Is what happens when we have all of our information in a table, okay? Now, in order for this graph to be a straight line, there's only one check that we need to do. And all we need to make sure is that X is increasing by the same amount every time, and Y is increasing or decreasing by the same amount every single time, okay? So as long as there's a consistent increase and decrease between all the X values and all the Y values, we have a linear function. So let's test it. What is the increase that's going on right now in the first graph for the X values? Alex? It's going up by 3. So put plus 3 at the top of each two numbers. Now, does anyone see what's the increase or decrease that's going on with all the y values? Aya? Minus 6. Now, all we care about is that it was plus 3, plus 3, plus 3, minus 6, minus 6, minus 6. Did anything change between this one or this one within the x or the y area? No. They were consistent, right? Now, if it was plus 3, plus 4, plus 5, that would be a different story. But since it's both the same, we're going to say this is linear. And we're good. Now, when we look at B, it's increasing by what in the x direction? Brady? 2. We're going to put a plus 2, plus 2, plus 2. Now, what's different about the y? Diego? It's increasing, but is it by the same every single time? No. What's the first increase? Seth? Plus 7. What's the second one? Jonathan?
11.
And what's the third one? Alex? 15. Plus 15. You see how all of these were different? If any one of them is different, it's nonlinear. Okay? If any one of them is different. Now, you might be saying, oh, you just got to look for the pattern, okay? But be careful. It has to be an addition or a subtraction pattern. Write that at the bottom. Has to be addition or subtraction pattern.
Oh, so it doesn't matter if it's being multiplied.
Correct. If it's being multiplied, guess what? Nonlinear, okay?
What if it's the top end? Like, you see how it's like 1 and 2?
Doesn't matter. Are you saying like if the x's were being multiplied by 2 and the y's were being multiplied by 2, wouldn't matter, it's still nonlinear, okay? Okay, the next two examples, again, don't copy them down, just follow along, okay? How many people need a little bit more time on this one?
Can I sharpen the pencil?
Yeah, go for it. Okay, we have an equation. The 1 and 2. Is 1 a linear function? Nick, what do you think? It sure is, okay? This one will be linear. What do you think about number 2? Linear function or not a linear function? Aya? You think it's linear? Is it a straight line?
No.
No. So it's not linear. It's easier than you think, okay? The only one that's a straight line that is not linear would be the vertical line, okay? Because it's not even a function, all right? Are we starting to get the hang of it? Okay, that's example number 1, okay? What we do with a linear function when it's a graph, okay? You just look that it's a straight line. Example number 2. Check out number 3. Remember, don't write this down. What's the increase or decrease in x?
1.
Plus 1, plus 1, plus 1. Is it consistent? Yeah. Yes, now let's check y. What's the increase or decrease in y? Nick?
2.
Plus 2. Consistent? Is it linear?
Yeah.
Absolutely. What about number 4? What's the increase or decrease in x? Carson?
1.
Plus 1, plus 1, plus 1. Is it consistent? Yes. Now let's check y. What's the increase or decrease in y? Yep.
Does it only have to be addition and subtraction?
Correct. What is going on with the y values?
Oh, then it's minus 8 for
Yep.
minus 4 and minus 2.
Is this consistent? Non-linear. Now, the reason I tell you do not look for a pattern, there is a pattern in the y values. What is the pattern? Liz? We are dividing by 2 every single time. Excellent. Now, but we have to stick with addition and subtraction. Are we cool? Okay? If you switch to division or multiplication, you're going to get it wrong. Okay? Only think on a 1-track or a 2-track train that it can only be addition or subtraction. Okay? All right. So we've got linear and nonlinear. We covered the tables. The very last example that we're going to do is next ones. Don't. Oh, whoops. Copy them down. Let's just do them together. y equals 3.8. Linear or nonlinear, and what are m and b? JJ.
Linear, and then M will be 3.8. And then we can make 3.8 and then B 0.
Super close. Super duper close. Gio, what do you think? Yep, JJ, you were right, but you mixed them up, okay? B is supposed to be 3.8, and M is supposed to be 0. Why? Why does M need to be 0 and not B?
I'm not gonna answer
Because it's
that. I wanna know if that's gonna be on the test.
Oh, yeah. Yep, Gabby? Very good. If not, if M was 3.8, it would be 3.8x.
Oh.
Okay? Because M is always attached to your x. What about the second one? Can we write that in terms of y equals mx plus b, Brady? Nope, this is nonlinear. And this one, y equals 3 to the power of x. Jonathan?
Okay. If the power is like on the y, so it's nonlinear, but if it's on the actual variable,
It doesn't matter where it is. It's
Okay.
always nonlinear. Okay, good catch. The next one, y equals 2 divided by x. Nick?
Because
Very good. Why?
because even though because the 2 is the m, because the 2 is over the x.
Correct. The x is in the denominator. Do we see the difference there? Okay. Next one. Y equals 6 times x minus 1. Linear or nonlinear? What do you think?
Linear,
Why?
because when you simplify it, y equals 6x minus 6.
Yep. You can distribute that 6, right? And we get 6x minus 6. Linear. What's my m? 6. What's my b? Booyah. And the last one, x squared minus y equals 0. Linear or nonlinear? Nick, what do you think? Nonlinear. Why?
Can you please send Aiden Rivera to student services?
Yes. Why, Nick?
Because the x is being multiplied.
Mm-hmm. The x is squared. Yeah, what's up, Jonathan?
Wait, is that the last one?
Yeah, that was the last one.
Oh.
Okay, 3 more that you guys need to copy down, okay? These 3. And then we're done, people. These are the last 3 problems, I swear. Do we think that is linear or non-linear? Don't be afraid to make a mistake. Diego, what do you think? Linear. Awesome. It's linear. Why? Very good. What's my M and what's my B in number 5? Seth?
M is 0 and B is 1.
I agree with one of these. If M was 0, would we have an X term at all? So what is M, Brooke? 1. Excellent. Do we see how, do you remember when you just have a variable, what number is automatically in front of it? That you don't see? A 1, right? So M is 1. Number 6, y equals 3x divided by 5. Jonathan, what do you think?
I put linear and m is 3 over 5 and x is 0.
Excellent. Very good. M is 3 over 5 and B equals 0. Is it starting to click for some people? A little bit? Because if we had 3 over 5, right? Y equals mx plus b. And we do y equals 3 over 5 times x plus b. Do you agree that making b 0 would get this away, right? And then we would get y equals 3 over 5 times x over 1. We just multiply the 3 and the x together and the 5 and the 1, and we get 3x over 5. Okay, number 7. Y equals 5 minus 2x squared. Amina. Very good. Nonlinear. Why? So remember, if it's nonlinear, are we gonna have an m and a b? No. All you gotta recognize was that there's an exponent, right, Gabby? And once you recognize that there's an exponent, it is nonlinear. Cool beans?